So you're going to notice in this problem, it is not linear, meaning it's not a straight line. This is actually called an exponential growth problem. That's kind of like what the coronavirus is. As more people get it, it goes higher and higher and higher and higher. It's exponentially growing. Okay, so if we get a problem like this, they might ask us to find the rate of change. Oh, whoops, not the rate of change. We can't find the rate of change because it doesn't have slope, but they might say find the average rate of change. Rate of change, and then they'll tell us between a specific increment, if I can talk today. Okay, so maybe they said 3 hours and 12 hours. Okay, so between 3 hours and 12 hours. Okay, and it really doesn't matter, but they will give you something there. So if they told us to find the average rate of change between 3 hours and 12 hours, what we're going to be doing is we're going to be finding the slope between those points, and that'll be our average rate of change. So first we need to find out what that's at. So 3 is at like, what is that? 1, 2, 3, 4, 5 tick marks between 10. So that means each of them count for 2. So that looks like it's at 3, 2. And if I look at 12, it goes to about there. So that's 12, 14, 16. So 12, 16. Okay, and this is just the average rate of change. So if we got it slightly wrong, that's okay. Now I'm going to type that into Desmos. So let's clear this out. Let's actually put these next to each other. Okay, so I'm trying to find it between these 2 points. Okay, so I've got to make my table. So I've got 3, 2, and I've got 12, 16. And remember, average rate of change is just the same thing as slope. So I'm going to use my cheat code. Okay, and my average rate of change is 1.55555, so it's 5 repeated. So my rate of change here, okay, that's just my m value, we said was 1.5 repeated. Okay, and it's important to note that I had to use the 3 hours, okay, and I had to use the 12 hours. Those are the points that I got to use in order to find the average rate of change.